Hello my dear students, how are you all? Welcome to Diksha Karnataka YouTube channel. I hope all of you are doing good. Okay, yes, so today, as I promised, is a practice session, an additional session for differential equation. I knew that I felt that some questions, some students might feel that questions are lengthier, so I wanted to come solve some more questions to give you more confidence in this chapter. We have done the concept part of this chapter, so we'll not talk about that. Only questions I've taken, I will solve that quickly and complete our session. Okay, so this is it for the session today. Okay, and one more thing, if you have, so we are in day 45 of our series 60 or 16 KCET mathematics in 100 days. Okay, so we are almost close to halfway of our series. Okay, we have completed calculus today. Okay, now next session will be on vector algebra. So most of the portions of PU2 are over. I have done questions on them, I've done your concepts, but a very important request from my side: if you have any feedback about the sessions that I've taken, if you want me to change something in the coming sessions. Yes, there was a request in the live session saying that, sir, I want more questions. So as you can see, I have started taking more questions in the sessions now. But any other request apart from the question side, okay, if you feel I should take more questions than this, let me know. Okay, so whatever the feedback you want to give, so sessions are getting longer, shorter, any feedback that you feel that will make your studies better, improve your your preparation, can boost your preparation, please let me know from your side. I just wanted to have a general feedback from my students. Okay, so that's just one request from my side. So today, as I said, we'll practice questions, nothing else. So I hope you're prepared. If you are not ready, pause the video or come back and see it later. But if you are prepared, do not pause it in between. Complete all the questions with me at once. If you start the video, finish the video, okay, and solve all the questions with me. If the question is getting lengthier, do one thing: pause the video, solve the question from your side, and then come back and check the solutions. Okay, so that is it. Let's start with the first question. Question number 1. If you see, again, I've not taken all the questions difficult, some will be challenging, but by now I feel that you will feel all the questions are easier only because we have done the concept, we have done the chapters. And good thing, today is the last day for our calculus of PU2, which was a very big portion, right? And we have completed our entire calculus of PU2. Okay, this is the last session on that. You'll have one KPL on the differential equation this Sunday, but this is the end of the conceptual video, the concept part, the question solving video for your calculus. Next class onwards, you have vector algebra coming for you. Okay, so fine. Again, this also is a very important topic because that also has a lot of weightage in your PU2 and your KCET if you're preparing for it, right? So that's why you cannot ignore that. It's not like we said calculus is over, so that's it, that's done. Achha, any more feedback about me also, I would like to please ask you to put that in the comment section. I would like to know you better, bacha. Anything that you want to say about me, about the sessions, whether it's positive or negative, I would take it positive. I will try to learn from it. I'll try to help you out in a better or the best possible way. So let me know. Okay, now first question: find the differential equation whose solutions are given in the following question. Okay, x square upon a square, y square upon b square equals to 1. Now we have to find the differential equation. Means, if you remember what is the differential equation, there are two terms. One is differential equation, okay, and the other one is solution of a differential equation. When I say differential equation, if you remember, for your portion you have only first degree differential equation, right? It means derivative will be only once, dy by dx. For derivative we do go to y2 also, but for integration, for finding the solution part, we don't go to second order integration. Okay, if you remember, I've done questions on that. We don't integrate twice, correct? So we have only first order in the case of integration. Over here we'll have second derivative, not a problem, that's easy to find. Okay, now so basically differential equation is what? A equation which consists of what? Differential derivatives. Differential means derivative, dy by dx. Okay, so what is this? This is a normal equation. It means that actually this is the solution of a given or any particular differential equation. Upon solving that differential equation, you'll get this as the solution. Okay, whatever solution is this? This is a particular solution. How come, sir? The constant is known. Okay, the constant is a known constant, so particular solution. So they are asking us for this particular solution, what is the differential equation? What is the equation formed with the derivatives? So we'll see that. How can we do that? By taking the derivative of this. So you can see right now it looks x square by a square, y square by b square equals to 1. So one thing that we know is, if I can substitute one variable for that, it'll make my work easier. Okay, so if I do that, have a look. If I show you this, if I take 1 by a square as p and 1 by b square as q. Now this whole thing will transform as what? It will become, just give me a second, this will become what bacha? P times of x square and about this plus q times of y square equals to 1. Okay, now take the derivative. First derivative if you take, what are you going to get for this first term? You're going to get 2px. 2px. What about the second one? 2qy y1. How come, sir? If you take derivative of y square, it's going to be what? 2y. But you have to do for y also, the chain rule. If you do for the y, it's going to be dy by dx. And we know that dy by dx can also be written as y1 or y dash. That's why. And next this will be what? 0. How come, sir? 1 is a constant, right? So 1 will be 0. Okay, now moving on. But we can see that in some question they have given second order derivative also, y2. So I'm going to differentiate this once again. But before going to do that, let me again keep the constant on one side and variable on one side. That will help me, do the calculation, this whole thing very easily. Let's see that. So how can I do that? First of all, I can cancel 2. Constant, I can take it on the other side. 0 by 2 will be 0 only. Okay. Now, I'll take this on that side. It will become px equals to minus q y1. Okay. And now I'm going to do what? I'm going to bring this q over here, minus q over here, and x over there. I'll get what? P upon minus q equals to y1 upon x. Okay. y1 upon x. Now, if you take derivative of this, I'll write it over here first. So what I have here as p by q y1 upon x. Take derivative now. So for this side you'll have what? A big 0. Constant. P and q are all constant. How come, sir? Please check. 1 by a square. If a is constant, 1 by a square is what? Constant only. Same goes with 1 by b square also. Check here. What about the right hand side? First of all, you check. There is a quotient rule. And then there is a product rule in the numerator also. So first we will apply what? First we will apply quotient rule. So if you do that, keep x as it is. And now take derivative of y1. For that you're going to get what? So if I keep y as it is, so for y1 I'm going to get what? y2. Please check. I'm keeping x, the denominator, as it is and differentiating the numerator. So if I differentiate numerator, again I have to use what? Product rule. So in the product rule of numerator I kept y as it is, and differentiation of the first derivative y1 will be what? Second derivative. So y2. This is clear. Derivative of the first derivative is what? Second derivative. So y2. Now I'm going to keep the y1, this y1 as it is, and I'm going to differentiate this y. Will become what? Will become another y1, sir. Please understand. I'm doing the product rule. First I kept y as it is and differentiated y1, got y2. Next I am differentiating y, keeping y1 as it is. So we'll get what? For y1 is y1. For y I will get as y1 again. Okay. So this is done. Next will be what, bacha? This is the end of the product rule. I have to continue with what? My quotient rule. So minus sign will come. This time, first we kept x as it is. This time we'll keep the numerator as it is, which is what? y1 as it is. The differentiation of what? X will be how much, sir? Simply 1. Okay. Divided by x square. Divided by x square. Bring this over here. This will become 0 again. What I'll have? I'll have x, y, y2. Okay, plus x y1 square, right? This is x y1 into y1 means what? X y1 square. So x y1 square minus y1. Okay. Now if I have to bring check the form, whichever is suiting, x y1. Okay, this is it. See, y1 I'll keep on this side and rest I'll bring over here. So I'll keep this over this side and rest. So I'm going to bring this over this side. Please check one. y1 equals to x y y2 plus x y1 square. Please check. I'll show you. y1 y1. Okay. Over here x y y2 and x y1 square. X y y2 and x y1 square. Option number, sir, simply A, sir. Not a difficult question, because of that, the combination of the product and the quotient rule at the same time, it looks complicated, but it is not that. So this is my result over here, and final result is here. Excuse me. So first I have the combination of what? Quotient and the product rule at the same time. Okay, please be careful while doing this step. This is very important step. This is the most important step. If you make a mistake over here, your answer will be wrong. Before that, you'll not make any mistake. After that also, you'll not make any mistake. This is the most important step. Okay, moving on. I hope this was visible. This also question number 2. This is a simple question. I think I've done a similar question or same question in our regular series. Okay, but let me solve it over here also. Y equals to e power minus 2x. E power minus 2x is given. They're asking us to, this is a particular solution. How come, sir? There's no variable. The constant is not there. C is not there. Okay. So for that reason, it's a particular solution given. I explained to you which is solution, which is the equation, differential equation in the first slide only. It's a particular solution of a differential equation. Now we have to pick the differential equation. How are we going to do that? By finding the derivative. So first find the derivative of this. You'll get what? You'll get y1 equals to what, bacha? Minus 2 times of e power minus 2x. Okay, now y minus 2, because for e power minus 2x will remain as it is, and for this I'll get what? Minus 2x I'll get it as minus 2. I want to find second derivative, will become what? Y2 will become what? Check here. So minus 2 is a constant, I'll keep it as it is, and for this again it'll be same thing, and I'm gonna get what? I'm gonna get for this thing again minus 2. My result will be what? Y2 equals to plus 4, because minus 2 into minus 2 is plus 4 times of what? E power minus 2x. Now this is my y2. Please check for y1 and y2 which option is suitable, because y2 is what? Second derivative, and y1 is what? First derivative. So if you see here, I can use the second result from here, b. What is the result? y2 because second derivative plus y1 because the first derivative, and minus 2y. Minus 2y. Please check it out here. 4 e power minus 2x for y2. 4 e power minus 2x. This is 4. Okay. Plus y1. What is y1, sir? Minus 2. So minus 2 e power minus 2x. And what is y? Check here. From here. So I'll get minus 2 times of this whole thing again. E power minus 2x. If you check very, very carefully, 4 times of this again positive. This minus 2 times negative, and this also negative. Cancelled. Answer is what? Answer is 0. So option B is actually correct, no? Can you see? I hope you can visualize this. I think I've done a similar question on this, but the answer is coming as 0. You can check it here. Okay. So I hope this is visible. Let's move on. Okay. So this was easy, no? This I hope you understand. Correct? Simple, very simple question. Y1 and y2 you find and substitute in the, you can check for all of it, but it was very visible from here. Y2 plus y1, if you see, plus 4 is there, minus 2 is there. It means 2 is left. Okay. If you take another 2 out of it, it will become 0. So B is the correct option. B is the, I did not write it over here. So B is my correct answer. Okay. Moving on. Visible, right? Yes, sir. So question number 3. Y goes to a cos x plus b sin x. Very simple question. Very, very simple question. Okay. This will be your homework. So this is your homework. I'll give you the answer. Okay. Solve and comment. I've done a similar question on this. Solve and comment what? You can see that. Got it right, sir. Option number. I'll see the option. Option number, what is it? GIR means got it right. I think option number C. Please check. Please verify. Okay. I don't remember exactly the option, but please check. If you get this option C, I think option C would be the right answer. But if you have any other answer for other than C, I will cross verify this anyway. But option C is correct. Okay. So solve and the comment. Got it right. Option number C. Okay. Chali, this is homework, bacha. Can I move on to question number 4? Very simple question, right? You can do it, no? Find derivative, first one. Cos derivative is what? Minus sine. Sine is what? Plus cos. Like that you can solve it. Solve the differential equation dy by dx equals to 1 plus y square upon 1 plus x square. Okay. Look complicated, but I know that few of you must have got the answer by now for this particular question. Yes? It's simple only, no? Bring this 1 by y square over here. And for this, bring this dx over there. Now after this, apply integral on both sides. This is the question where differential equation is given. They're asking the solution. Now you tell me what type of solution you're going to get. Okay, you're going to get only general solution, because there is no boundary condition given for x and y to find what? To find the constant value. For that reason, the solution that you're going to get for this differential equation will be what? General solution. If you want to get a particular solution, you need to have the x and y values known. Okay, चलिए करते हैं इसको. So tan inverse, okay, this is tan inverse of y, this is tan inverse of x plus the constant c. Okay, now bring this over here, correct? So tan inverse of y minus tan inverse of x equals to c, correct? Please have a look. Now I can tan inverse of a minus tan inverse of b, the formula you remember, tan inverse of a minus b will be tan inverse of a minus b upon 1 plus ab. Okay, bring the tan inverse on that side, you're going to get what? Y minus x upon 1 plus xy equals to tan c, equals to tan c, my final answer. See, tan c, if you want I can write it again as constant, another constant, maybe k or p. So let's write it like this, final answer, y minus x upon 1 plus xy equals to p. P is the constant, p is the constant, but we use p in the linear differential equation, no? So I write it as k only, not p. K is the constant. What is this? A constant. Done? Simple question, sir. Yes, you can solve it from your side. Also the formula, if you have to remember, this is also the most important step, the formula you have to remember. Okay, now if in the question they have given this as the answer, let's say optional is given, this is the answer, then you pick this as the answer. If they have given this as the answer, you have to solve it, solve the two more steps to reach this answer. Okay, so visible. Moving on to question number 5. Question number 5, chaliye. Solve the differential equation e power y plus 1 cos x dx plus e power y sin x dy, okay, equals to 0. Okay, कर लेते हैं, let's solve it. So I can do what? I have to make dy by dx on one side, okay, or I have to use the method. What method I have to use? Variable separable method. Please see which will work out. So sin x and cos x I can see over here. So I'll try to bring it on one side. For that I have to what? Bring the whole thing on the other side. This whole term I'll bring it on the other side. It will become e power y plus 1 cos x dx equals to minus e power y sin x dy. Simple. Now bring this sin x over here and this e power y term over there, because you will have one variable on one side. So basically I'm applying what? Variable separable method. So what I get? Cos x upon sin x dx equals to what, bachcha? Minus e power y upon e power y plus 1 dy. So variable separable method is applied now. Use the integration. Okay, now before doing the integration I can make some changes over here. So I'll make on this side integral of what? Cot x dx, cos by sin is cot x. What about this side? I can take minus side, minus common. Okay, now for this I will use some substitution. Please check. I'm going to use e power y equals to t, differentiated over here, e power y dy by what? E power y dy by dt equals to 1. Okay, dy by dt equals to 1. So I get e power y dy equals to, okay, what? Simply dt. Yes, I have taken e power y as t. So e power y differentiation will be what? Dy by dt equals to 1. So e power y dy equals to dt. Now e power y dy I have here. Please check. E power y dy I have here. So I can write that as dt. This whole thing will become dt upon, now e power y is what? Is t. So it will become t plus 1. Now let's see the integration over here. I can do it, do the step on this side. So cot x will be what? Integration. I'm doing this integration over here. Cot x will be log sin x log mod of sin x, okay, and on this side I'll have minus of log of t plus 1. Please check, minus of log of t plus 1, and since I have log and log everywhere, I can take it as plus log of c. Well, how come so? Because I can use the property. Okay, now I'll write it the same thing over here in this slide. Log of sin x equals to minus log of mod of t plus 1 plus log of c. I hope you know that why I'm doing this. Why I'm doing mod all the time, because log will log, what is the domain of log? Always positive. Okay, yes, Shari. What is the formula if you remember? Log of a minus log of b is equals to what? Log of a by b. Yes, please check. So I can write it over here on the RHS side. Keep this as it is. It will become what? Log of c minus log of t plus 1. Please check. This is t. Log of c minus log of t plus 1. So this will become what? Minus, sorry, not minus. Minus is gone. This whole thing will become log of c, right? Okay, one second. Yeah. Okay. Yes. So, bacha, basically I have done one thing. I can take this now over here also. 1 plus ey as t. Even that will not make a difference. Can you see that? If I take 1 plus ey, instead of taking it as log of t plus 1, answer will be same. I can take t, over even this as the t, okay, but I can take log of, so one change, I want you to do like this. 1 plus ey equals to t. If you take, this will be what? 0 only, no? 0 plus ey. So the same thing will be happening, but instead of having this now, I'll have only t over here. Result will be same, okay, but just in case, okay. So I am saying that for this you will not have t plus 1, you will have t, okay, you will have just t. Okay, no problem. Alright, now you can write like t plus 1 also, but just in this case I am using this way. I am going to get what? Log of c by t. C by t, please check here. C minus log c minus log t. So log of c by t. Now you can see here log and log. If I apply exponential function on both sides, the effect will be cancelled. How can I apply? I can use the same function, okay, same operation on both sides. It will become what? Mod c. Now put the t value. What's the value of t? C upon e power y plus 1. As I said, you can keep it as t plus 1 also, but I wanted to take it like this. Please check here. You're gonna get what? Mod of sin x times e power y plus 1 mod equals to mod c. Any option like this? Yeah. If you want, you don't have to take mod. You can just write it like this. Final answer without mod also. Sin x e power y plus 1 equals to c. Please check. Option number B. There is one confusion I created. Let me resolve it. Instead of taking as e power y as t, I am asking you to take as 1 plus e power y as t. No difference. Okay, just this substitution will become what? Simply t instead of t plus 1. So I am saying that take it as just t. Okay, take it as just t. So log t will come. Okay, simply log t will come, bacha. Okay, okay, sir. This is it. Answer is B. Correct. Sin x e power times of e power y plus 1 equals to c. Okay, great. So please have a look. I hope this is visible. Yes. Okay. Now question number 6. How will you solve this question number 6? Check it out. Log of dy by dx. Okay, I have to free the log from, I have to free the derivative from the log. How can I do that? Take exponential function on both sides. Please check. So I can write this first of all, the question as it is. Log what? dy by dx, okay, equals to ax plus by I have. Yes or no? Now take e, exponential function on both sides, like this, e and e. E and log will cancel the effect, will become what? simply dy by dx. And what will this be? E power ax plus by plus exponent is positive. It means what? Means exponent is added. It means what? They're in product. So I can write this another step as dy by dx equals to e power ax times of e power by. When the base is same, you add the exponent. If the exponent is added, you can split it like this. Okay. Now do one thing. Use the variable separable method. So bring y term over here and x term over there. So you'll get dy by e power by, okay, equals to e power ax dx. Variable separable method. Now integrate it. Okay. So I can write this as integration of e power minus by dy equals to what is this? E power ax upon a plus c. Please check. Integration of e power ax is what? E power ax, but this a is there. Multiplied with x, I have to divide by that. Over this side I can do it again. What I'm going to get, please check. E power minus by upon minus b equals to e power ax upon a plus c. This is my final answer. Just the minus sign will come in numerator. So minus any option like this. Okay. E power minus by minus b equals to e power ax plus. Okay, this is the answer. Please check. Correct. E power minus by upon minus b equals to e power ax upon a plus c. So option number D is correct, sir. Simple question, very simple. Okay. So I hope you got this. Okay. Now moving on. Question number 7. Question number 7. Solve x plus y the whole square dy by dx equals to a square. Okay. Now you can see here. Right now, if I take this, it will become x square y square 2xy with dy by dx. Makes our work little difficult. But if you remember, we can use something called as substitution. So if I substitute this, I've done a question, I think 2-3 questions or more than 2-3 questions on the differential equations where we use substitution. I think I've done almost 7 to 8 questions on substitution of the differential equation. So what I'm going to do, take x plus y as a variable v. X plus y equals to a variable v. Please take the derivative now. What are you going to get? For x, it will be just 1. For y, you're going to get what? Dy by dx. For v, what are you going to get? Simply dv by dx. Correct. Now I want the value of dy by dx. So from there I can do what? I can write dy by dx equals to what? dv by dx minus 1. Okay. Now use this condition. So x plus y will become what? Will become v. So v times of what? V square, right? V square times of dy by dx is there. So I'll write it as dv by dx minus 1 equals to a square. Please check. Correct. For dy by dx from here I can write it as dv by dx minus 1. Now bring this v square on that side. I'll get what? Please check. dv by dx minus 1 equals to a square by v square. Correct. Now bring 1 on that side. I get what? I get excuse me, dv by dx equals to a square by v square plus 1. Okay, very simple. What is going to be a square plus v square upon v square? Okay, and this is dv by dx. All right, now I have to keep the dv on one side. I have to apply the variable separable method to do the integration. So I'll write it over here first. What I have, dv by dx equals to a square, what is it? A square plus v square upon a square plus v square upon v square. Use this, bring it over here. You're gonna get what? dv times of v square upon a square plus v square equals to dx. Okay, so I can write it like this. Please check. V square plus a square minus a square for the LHS side, and dv will be there obviously, upon a square plus v square equals to dx, both in the integration. I've used this type of questions multiple occasions in the integration. I've written v square as v square plus a square minus a square. So they'll cancel each other. Why I've done that? Because see here, v square by a square is there in numerator, over here also numerator. So if I club them together like these two steps, so if I club them together like this and this, I'll get a separation over minus sign. So how will this look like? Please have a look. Integration of what? I'll get v square plus a square upon v square plus a square minus a square upon, correct? Again this will be also under integration, dv. What is this equals to? Simply x plus c is there obviously, okay, plus c is there. Now have a look. I can write this what? This is simply integration of 1 dv. dv is there bacha, dv is there, okay, minus integral of what? I can write a square outside, integral of 1 upon a square plus v square dv equals to x plus c. So if you check here, this is simply what? V minus, this is simply a square, and what is going to be? 1 upon a square plus v square, or a square plus x square, tan inverse of formula, particular function. So it will become what? 1 upon a tan inverse of v by a equals to x plus c, correct? Now I can cancel this a with a square. Now put the value of v back, x plus y minus a times of tan inverse of x plus y upon a equals to x plus c, correct? Now this x and this x will cancel each other. What I have left now? I have this y left on the LHS side. I'll bring this whole thing over there. I get a positive times of tan inverse x plus y upon a plus c. A tan inverse x plus y upon a plus c. Okay. See, simple question. Okay, we have to use the substitution. So we have used what? X plus y equals to v, correct? You can do it, right? X plus y equals to v, 1 plus dy by dx equals to dv by dx. Okay, and then we have used this division, sorry, the derivative of dy by dx substitution in the question as dy by dx minus 1. Rest all was the steps that we had done, and over here integral. Okay, for integral we have to use what? Plus a square minus a square, that we did, and we got two terms, integration in two terms. This was nothing but 1, this was tan inverse, and the result is what? Y equals to a times of tan inverse x plus y upon a plus c. C is the constant here. C is the constant. Please check. From the beginning, option number C is correct. So for now question number 8, okay. For the question number 8, what they are asking? Solution of cos y dy by dx equals to e power x plus sin y plus x square e power sin y. Okay. Now one thing that we can see over here is what? Please check. I have sin y over here and sin y over here. With the power e, I can separate that. Let's see what will happen. So I'll write it like this: cos y d by y dx equals to e power x times of e power sin y plus x square e power sin y. I can take it common, bacha. Then the sin y term will be different. I can put it on this side of y, variable y dy. So please take e power sin y common. What I get now? I get e power x plus x square left on this side, e power x plus x square left on this side. So what is this going to be? Cos of y dy y dx. Now bring e power sin y over here and dx on that side. It will become what? Please check. Cos y dy. I'm bringing what? I'm bringing e power sin y over here. So e power sin y. And for this side I'll get what? E power x plus x square dx. Use the integration on both sides. Now please check. If I use a substitution as what is it? Sin y as t. What is this going to be? You'll have what? You'll have cos. You'll have cos. So you'll have cos of y dy equals to what? dt. Okay. So cos y dy will become what? dt. So please check. You'll get e power Yeah, you'll get this as dt upon e power what bacha? T. Integrate on this side, you'll get what? Simply e power x. For e power x, for x square you're going to get what? X cube by 3 plus c. Okay, what is the integration of this e power minus t? Simply e power minus t upon minus 1. Yes, this is e power t in the denominator will become what? E power minus t. What is the integration? E power minus t will remain as it is, divided by minus 1 e power x plus x cube by 3 plus c. Now put the t value. So what is the t value is? Sin y. Okay, so my final answer will look like this. I have a space over here, so I'll write it like that. E power, first I'm going to write this. So minus e power minus t equals to what? E power x plus x cube by 3 plus c. Please check. Correct. Now put the value of t. So minus e power sine of x equals to e power x plus x cube by 3 plus c. I'll bring everything on one side and constant on one side. It will become what? E power x plus x cube by 3, and this will become what? Plus e power minus sine x, okay, equals to minus c. Minus c is a constant. I can write another constant for that. Final answer is e power x cube by 3 plus e power minus sine x, and for the constant minus c I can write it as simply okay. Your final answer, e power x plus x cube by 3 e power minus sine x. Okay, please have a look. Okay, from the beginning, this is the substitution over here. The integral is like that. Okay, now question number 9. Question number 9, chaliye. X dy by dx equals to y minus x tan of y by x. I can see y by x is coming. Okay, even if I divide x on this side, I get y by x. So something must be forming over there. I have to use substitution again, but let's see. So I'm going to write this as dy by dx for the question number 9. Okay, please try to solve it from your side if you can. Simple question. Okay, but I'm going to solve it anyway. So if you want to solve it from your side, pause the video, solve the question, come back and check the solution. Okay, so I can write it as dy by dx y upon x minus x upon x. So I'll write it like this only for the first step. Tan of y upon x. X and x will be cancelled. Now take substitution y upon x equals to, let's say, v. So what is y equals to? Vx. Do the differentiation. Dy by dx equals to, keep v as it is. X differentiation is 1. Next what? Keep x as it is, and differentiation of v. So dv by dx. Okay, use it in this place. So I get what? V plus x dv by dx, okay, equals to y by x is how much? V. So v minus tan of v. Okay, now v and v is cancelled. Please check. So now what I have x dv by dx equals to minus tan v. Okay, minus tan v. Okay, now bring this over here. So you're gonna get what? Dv upon tan v equals to what? Minus dx upon x. Correct? Minus dx upon x. Now I have applied the variable separable method. I'm going to do the integration now. How? Like this on both sides. Please check it out. Integral of what? Dv by tan v equals to integral of negative of what? Dx by, what is it? Dx by x, sir. Dx by x. Okay. So if you check here, what will this become? Integral of cot v dv equals to minus log of x plus log of c, again the constant because log is there. What is the answer over here? Please check. The answer would be what, bacha? For this I have log of sin x, okay, equals to log a minus b again. So log of c by x. How come, sir? Please check. Log of c by x, because c is there x is there, log a minus log b. So log c by x will become, log and log you can cancel. So this is all again all under the mod only. All of this is under the mod. Okay. So what I get? I get sin x equals to, mod sin x equals to c by x. Is this an option? Sin x equals to c by x. Okay, sin v, no? This is sin, okay, I've written here wrong. This is not sin x, this is sin v. The variable is v over here. Sin of v. What is sin v? Sin of y by x. Okay, equals to c by x. This is my final answer actually. Okay, 1 second. This is your final answer. Please check. Sin of y by x, c by x, all in the mod, option number D. Okay, I think I've solved a question like this, right? I think question number 2 or 3, similar to this it was. Okay, can we check? Which question was that? Was it this one? Right? It was this one only, right? Yeah, similar to this. Okay, correct. We had sin x times of e power y plus 1 as c. Correct. This question. Fifth is same as, very similar to ninth one. Okay, please check. Ninth one, so answer is, what's the answer? Sin y by x, the mod in the mod equals to mod of c by x. Yes, option number D is correct. Yeah, moving on to the last question of the day and the calculus that we're going to solve, okay, in our regular sessions. We will come up with a revision, we'll do whatever we can to help you out, but for the regular session, for the series, this is the last question of your calculus. Okay, integrating factor of the differential equation dy by dx plus 2y 1 minus y upon x. When we talk about IF, whenever we are dealing with linear differential equation, sir. So we have to make two forms. There are two forms for that. I'll revise it quickly. We have done in the previous session. First one is dy by dx, where x is the independent variable. We'll have this as plus p y equals to q, where p and q will be in terms of what? In terms of x. Second form is what? dx by dy plus again px equals to q, where p and q will be what? In terms of y. Correct? Okay. So for this, I have to make this form first. So please check for the condition which is given. I have dy by dx plus 2y. Separate this because it is in terms of x and y both. Separate it 1 by x minus y by x. Bring this y over here. Bring this y over here. So what are you gonna get? dy by dx plus 2y plus y upon x equals to 1 upon x. Okay. So I can write it here. dy by dx plus take y common. I get what? 2 plus 1 by x equals to 1 by x. Does this match with any of the form? dy by dx yp. Please check. yp plus q. This is this whole thing is p and this thing is q. And p and q should be function of x, sir. P and q should be function of x, where derivative is dy by dx. Okay. Now p value I'll write it from here. That's what important for me. P is what? 2 plus 1 by x. 2 plus 1 by x. Okay. Now we know that integrating factor IF is given by e power integral of p dx in this particular case. So apply it here. E power integral of what? Please check. Integral of, what was it? 2 plus 1 upon x dx. Am I right? Yeah. So this will become what? E power 2x plus log x, right? E power 2x plus log x. Okay. And how much is that? E power 2x will be what? As it is, so e power 2x. Okay. And what about this? Times of e power log x. E and log will cancel its effect. Answer is what? Simply x. So I get x times of e power 2x. This is what? The integrating factor. This is my integrating factor, sir. X times of e power 2x. X times of e power 2x. Have a look. Remember these two forms, okay? And From after that you get, put the value of p in the integration factor expression that we have for this, e power p dx, and then integrate it, you're going to get the answer. If you have to find the result, final answer, what are you going to do? Tell me. Okay, so this was in y, no? So we'll write y times of if equals to integral of what? Q times of if dx. Okay, you have to integrate it again. This is the final solution, no? This is the solution, bacha. Okay, not required for our case. Our case, they have only asked what? Please check. They have asked the integrating factor. So the answer is x times of e power 2x. X times of e power 2x. I hope this is visible. I hope you found this session to be helpful. Okay, so I hope you were able to solve all the questions with me. Okay, so this is it from the calculus side, bacha. Next session we'll start the vector algebra. So if you want to get the sessions better, please revise through the NCRT and then come from the further sessions. So whenever you're having the session, no, this is for KCET series, right? Please revise the NCRT, even though you have done in the school, done in the college. So please revise the NCRT. When you come for the session, when you watch the session, you'll be able to understand the concept very easily. Okay, you'll have the doubts very clearly that, okay, this is my doubt, sir. I can ask you in the comment section. Okay, any doubts, any queries, any feedback, let me know. I'll try to answer your queries. Okay, I'll try to resolve your queries. For now, please take care. Bye bye. Okay, and keep working hard. Don't forget to keep working hard. The time is getting lesser and lesser for your exam, so keep working hard, keep smiling. Okay, keep a positive surrounding. Keep a positive surrounding for you, and I'll see you in the next session. Please take care and bye bye.